Let's look at our next example. We want to evaluate the function x over the square root of x plus 1 minus 1 at several x values near 0 and use the results to estimate the limit. So I want to use the results to estimate the following the limit. The limit as x goes to 0 of my function. So what it's asking us to do is fill in, kind of create a table like we did in the last example. But now when I'm making my table, I want to get closer to the number 0. If I plug in 0 into my function, it's undefined, so I'm just going to leave question mark again there. And you need to find values that are smaller than 0, so negative, and you want to stay pretty close to 0. So I'm going to pick the following. One more 0. Okay. And then you want to pick some values a little bit bigger than 0. So again, pretty close. I'm going to pick some really small numbers here, just so I get close enough to 0 to know what's going on. And I'm going to take these values right here, my x values, and plug them into my function up here. Use a calculator to get the decimals here. So I'm getting 1.99499, 1.99950, 1.99995, and then for the ones bigger than 0, 2.00005, 2.0005, and 2.00499. So we want to know what this limit is. So I got to look, again, read my table off. If I approach 0 from the left, so if x approaches 0 from the left, what's going on with my y values here? What do they look like they're getting closer to? They look like they're getting closer to the number 2. So I'm going to guess that f of x approaches 2. Now we also need to look at the other side of this table as I approach 0 from the right. X approaches 0 from the right. What happens to my y values? What do they look like they're getting closer to? It looks like they're getting closer to the number 2. So f of x approaches 2. So then our guess, based on this table, we would say that we believe the limit is 2. So we believe that the limit as x goes to 0 of our function is 2. You could also look, if you want, at the graph of this function. That would maybe help you confirm that this is indeed the limit. So to verify this, we can graph the function. Now the domain for this function, the domain of this function here is going to be from -1 to 0, but not including 0, and then 0 to infinity. Because we have a square root here, we can't take the square root of a negative number. And so our domain cuts off. It starts at -1. And if you ask your calculator to graph this function, you'll see the following picture. Remember, my function is undefined at 0, so there's a hole. And your graph looks like this. So graphically, if I approach 0 from the left, I'm getting closer to the y value 2. If I approach 0 from the right, I'm getting closer to a y value of 2. So one final comment I want to make here for this problem, note that your function f of 0 is undefined, but this has no bearing on the limit of your function. When you're computing a limit, you don't care what's happening at that particular value. So in this case, I don't care what's happening at x equals 0. When you take a limit, what you're concerned with is what's happening around x equals 0. So really close by, but not exactly at 0.